Hi guys, and welcome back to my channel. In this video, I'm taking you through triple integrals in spherical coordinates. I have a problem for us to solve. It says convert this integral into spherical coordinates and solve. So you can clearly see that we have this integral in the Cartesian coordinates. Our goal is to convert every coordinate you see here from Cartesian to spherical, then after we solve the integral. How do we do that? So in our previous video, we solved a problem also converting a Cartesian coordinate into a spherical coordinate, right? So kindly visit those videos so you get the better understanding. In this video, I'll move straight away do my conversions. So first of all, you realize that integral in spherical coordinates is in the form the rho, the theta, the phi. Okay, so for the sake of clarity, let me write it back again. So our integral in spherical coordinate generally is given as integral from delta to gamma, integral from alpha to beta, and integral from c to d of the function rho squared sine phi, right? Function f of rho sine phi cos theta, comma rho sine phi sine theta, comma rho cos phi. So you have our d rho, the theta, the phi, right? So this is a general representation of spherical coordinates, and this is a general representation of an integral represented in what? A spherical coordinates. Okay, so with this given here, if you want to find all the parameters in this equation, we will look out for it from this side. Okay, so let's see something. The x here, the z here goes in for our inner limit, x goes in for here, then y goes in for the outer limit. So all this will contribute to what? To the limit of what? Rho, theta, and the phi. So from the first one, z will be greater than or equal to the square root of x squared plus y squared, and less than or equal to the square root of 18 minus x squared minus y squared. So this side I'm going to have z to be equal to, so let me say z squared will be equal to x squared plus y squared. Then I also have z squared to be equal to 18 minus x squared minus y squared, which is also the same as z squared plus y squared plus x squared is equal to 18, right? From this section, I can find a parameter rho because in spherical coordinates z squared plus y squared plus x squared is the same as what? Rho squared, and it's equal to 18. So rho will be equal to the square root of 18, that is 3 square root of 2, right? Now let's move to the second one, theta, and that will be correspondingly x, right? So x is greater than or equal to 0 from this side, less than or equal to square root of 9 minus y squared, right? 9 minus y squared. So I'm going to have x to be 0 and x to be equal to root of 9 minus y squared, and our x squared will be equal to 9 minus y squared. So you're going to have x squared plus y squared to be equal to 9. And realize that from polar coordinates, x squared plus y squared is the same as r, right? So you're going to have r to be equal to, r squared to be equal to 9, and r will be equal to plus or minus 3. But already x is greater than 0, right? S is greater than 0. So meaning r will be equal to 3, okay? Now let's put all this thing down. Finally, we're going to have y to be greater than or equal to 0 from this side, and less than or equal to 3. Okay, so what is this going to help us do? So graphically, we are going to represent this here. Our x is what? On the right side, right? S is equal to 0, and y is what? At the upper. So meaning that we are dealing with the first quadrant. Y is what? From 0 up. and x is from right here. So meaning that we are in the first quadrant. Once you get to know we are in the first quadrant, the first thing that should come in mind is that we are above 0. So our row, we got row to be 3 root 2. So the first interval of the row is greater than or equal to 0, less than or equal to 3 root 2. That's the first interval. The second interval, once you're in the first quadrant, is your theta. Okay, it will be your theta. So for our theta, since we are in the first quadrant, we are going to have our, okay, let's do the, so from here, as I'm saying, theta is falling here, right? So once theta is falling here, then we're going to have our angle to be equal to 0 less than or equal to theta less than or equal to pi on 2. Now, this thing that we have here, z squared is equal to x squared plus y squared. This one is a cone, okay, is upper half of a cone. So also that gives us the clue that it's still going to be in the first quadrant. Okay, now let's see something here. So at this point, we have the limit for our theta, then finally phi. But we can only get phi from the equation r is equal to rho sine phi, or z is equal to rho cos phi. Since we have r to be 3, we can use that to find, and rho is 3 root 2, right? Sine phi. So with this, I'll divide through by what? 3 root 2 over 3 root 2. This cancels this, and I'll have sine phi to be equal to 1 over square root of 2. Therefore, I'll have my third interval to be equal to phi to be greater than or equal to 0, but less than or equal to pi on 4, right? Yes. So we have all these sets. The next thing is to convert our integral straight away. So my phi will be the outermost, 0 to pi on 4. The next one is going to be my theta, 0 to pi on 2. The next one also is going to be from 0 to 3 root 2. Then also take note, x squared plus y squared plus z squared here will be represented as rho squared. Then we introduce our constant here. So you're going to have rho squared sine phi, okay? So once you have that, we introduce our the rho, the theta, and the phi. That is all. So let's solve this and we are good to go. So once you have this here, what do you do? Once you have this here, you're going to integrate everything with respect to what? All that you have here. So 0 to pi on 4, 0 to pi on 2, 0 to 3 root 2. This becomes root to the power 4, sine phi, the rho, the theta, the phi. So firstly, we have to integrate with respect to rho. We're going to have integral from 0 to pi on 4, integral from 0 to pi on 2. Then our rho becomes rho to the power 5 over 5, right? From 0 to 3 root 2, sine phi d theta d phi. When I put 3 root 2 inside, what am I getting? So just open your calculator and you punch this. So you're gonna have, so we shouldn't focus on this now. 0 to pi on 4, 0 to pi on 2. Wherever I see rho, I'm gonna put 3 root 2 because when I put 0, it will be 0, right? So you're going to have, let me punch that straight away into the calculator. So if I have 3 root 2 to the power 5, then my denominator is 5, right? So I'm going to have 5. So that is going to give me, so let me make it this way. So that's going to give me 970 over 5. Okay. Then sine phi theta d phi. Next, you're going to integrate with respect to theta. Since there is no theta term, you just introduce theta. So 0 to pi on 4, 970 over 5. Okay, let me make it this way. So I'm gonna have open bracket 3 times 3 Okay, so I think that 3 root 2 to the power 5 is going to give us, I think I'm using a scientific calculator. So you let's maintain this as you have here. I think there should be simplification, right? But you let's maintain this. So this may be an approximation. So at this point, you just bring your root 2, then our what sign of the expression phi, right? Sign of the expression phi. Then we are going to introduce our theta because we are integrating with respect to theta. So theta will come, then it will be from 0 to pi on 2, right? 0 to pi on 2 d phi. Yeah. So at this point here, we're going to have our integral from 0 to pi on 4. Then I'll have my 970 out over 5 out 2. Then finally realize that wherever I see pi theta, I'll put pi on 2, right? So I'm gonna have sine pi times what? Pi on 2 pi. So obviously pi on 2 can come out of the box. So we're going to have 970 over 10 root 2 pi, right? Integral from 0 to pi on 4, then sine pi pi. Okay. So as simple as that, we are left with this. This is the same as what negative cos, right? Negative cos of that. So once you have this, we are done. Alright. So let's see. This becomes 970 over 10 root 2 pi. Then this is going to give us negative cos, right? Negative cosine of the expression theta, right? From 0 to pi on 4. So we are going to have theta as what? Pi on 4 and theta as 0. So theta as pi on 4. So having theta as pi on 4, we are going to have, so here should be phi, not theta, okay? Here should be phi. So cos 45 is going to be negative cos 45, so 1 over root 2 minus what? 1, right? Yes, 1 over root 2.